What happens if one of the x's is equal to 1? One switch is closed and the other one is open. The light is still off. So it requires both switches to be closed, right? So that's the AND logic. X1 and X2 has to be equal to 1. Okay? The next circuit here, what happens if only one X is equal to 1? Only one switch is closed. The light is on, right? So as long as at least one X is closed, is equal to 1, the light would be on, right? So this circuit represents the OR circuit, OR logic. That makes sense? Let's see a combination of series and parallel structures here. Then what would be a function of this circuit? Combination of AND and OR, right? So what is it? Function of the light would be equal to function of x1, x2, and x3 equal to x1 plus or x2 and then total and with x3, right? Because x3 has to be equal to 1 and at least one of x1 or x2 has to be equal to 1, right? Okay. The next one is inversion or the not logic, the complement of a logic. Okay, inversion. So it is a function of a variable, only one variable. Function of it would be equal to the inversion of that variable, right? So we use this, we can write it this way. So there are many ways to represent this logic. Okay, they are all the same, representing the same thing. Okay. So if a function has more than one variable, like this, the inversion of the function would be equal to when you put a complement on the top of the whole function, right? And how to get to the last equation here, last expression here? Applying what is the law? Boolean law that we are using to get to this expression. De Morgan, right? De Morgan. Remember that? Yeah? You cannot forget. So you have to do the review by yourself. Okay, go back home and review what you learned from. If and only if means no. That one. If and only if is a bidirectional statement, right? If the other one is called implies. P implies Q, right? If P is true, then Q must be true. But Q doesn't give you any information about the P. No clue of what you're talking. So let's talk about that later. I don't think it's related to what we have right now. Okay. Okay, we still have a lot for this chapter. Okay. Let's see the circuit, a circuit for an inversion here. What happens if x is equal to 1? What would happen? Means that the switch is closed. What would happen to the light? On or off? Who say on? Raise your hand. If x is equal to 1. Who say off? Raise your hand. It would be off. No light. When x is equal to 1. Because this path would be closed, right? So the ground here would be, this point, the voltage would be equal to 0. At the same voltage level, 0 and 0, there would be no current going through the light. Okay, so it would be like short circuit. Because here, see, this is just like a wire, right? The switch is closed. So this point, the voltage would be equal to this point, which is a ground, right? So if x is equal to 0, then this path would behave like open circuit. Open. So current would go in this direction because the voltage, current flow from high voltage to low voltage, right? So the light would be on when x is equal to 0. Right? On means 1. See that? Okay? And the next figure in the text